Hi, Assalamualaikum. Today we're going to do the chapter on the non-traditional machining, and the content for this video, we will look into the introduction of non-traditional process, the classification of non-traditional process in which we have mechanical energy, electrochemical machining, chemical machining, and thermal energy processes. And we also look at the application consideration. So let's look at the definition. What is non-traditional? Non-traditional machining means that it's a process removal of material but using mechanical, thermal, electrical, and chemical energy. And sometimes they combine this energy. It also doesn't involve with use of sharp cutting tools, traditional machining. And this is applied to the new and unusual machining requirement based on the new developed metals or non-metals with special properties in which to make them difficult to process or to do the removal using the traditional machining. And usually it also for the complex part geometry, and if need to avoid any surface damage, so they have to use the non-traditional machining. So work material for non-traditional machining involve metal and non-metal, and some of the processes only can apply to metal. Some of the processes only can be used on metal because they need to have the conductor for the process. For example, ECM, EDM, and also wire EDM, and also plasma arc cutting only apply for metals. Possible part geometry features non-traditionals are specifically for the very small hole with a large depth to diameter ratio, holes that are not round, okay, narrow slab like this, okay, small narrow slab, micro machining, and some other part geometry that not applicable for the traditional machining. And the classification of non-traditional process, we can see the first one is mechanical, in which involve with the mechanical action in erosion of work material by high velocity stream of abrasive or fluid. Sometimes they combine the fluid and the abrasive. Electrochemical involved with the electrochemical energy to remove material, in which the reverse of electroplating, and the chemical in which involved with the chemical agents selectively remove material from the portion of work part. This one is applied for the electronics industry, and for the thermal energy usually applied to small portion of our surface, in which the portion to be fused or vaporized. So there are 4 classifications for non-traditional. And you can go further by looking at this table in which they have the process involved from the 4 category, and these are the characteristics, and these are the cutting speed, and also they give some of the parameter of the process. Okay, we look at the first one, mechanical energy process, in which typical form of mechanical action is erosion of work material by high velocity of abrasive or fluid, in which water or sometimes combination of abrasive and fluid. So under this category, we have the ultrasonic machining, and then we have the water jet machining, we have the abrasive water jet machining, and we have abrasive jet machining. So don't get confused with these 3. This one is using water only. Okay, this one is combination of abrasive and water, and this one is just abrasive only. Okay, that's the difference. Okay, let's go to the first one, the ultrasonic machining, in which abrasive contained in a slurry are driven at a high velocity against work by a tool vibrating. Okay, these are the tool at low amplitude and high frequency. So the tool oscillation is perpendicular to work surface. Okay, and the tool is fed slowly onto work. So the application for ultrasonic machining is for hard, brittle work materials such as ceramic, glass, and carbides, and also success on certain metals such as stainless steel and titanium. And they have the coin operation, in which pattern on the tools is imparted to a flat work surface. So they are following the shape of the tools. Okay, so we can see here these are the video on the ultrasonic machining, and we can see that it apply in the medical, dental. Okay, these are the milling, ultrasonic machining. You can see it move very fast. Okay, so these are the application mostly. So usually it's done with the CNC because they have a very specific geometry involved. Okay, these are for the medical. They have the bone plate, dental application. They are very fine. Okay, and all are done with the CNC. Okay, next let's look at the water. Okay, they are using water to cut, in which the water must be high pressure, high velocity stream directed at the work surface for cutting. So we can see that these are the diagram for the water jet machining, in which they make sure that water at the high pressure, high velocity, and they must have drain for the water to go out. Usually controlled by the CNC. And the advantage is no crushing or burning of the work surface because we're using water, minimal material loss, no environmental pollution, ease of automation because it can be applied with the robot or CNC. The disadvantage, it will take long time and not suitable for mass production, okay, because of the high maintenance involved water. So we can see here that the water jet is cutting a very thick slab of steel used to cut narrow slit in the flat stock and not suitable for brittle materials. So these are the process. Okay, you can see that's very thick plate they are cutting using the water jet machining. And this one is abrasive plus water. So they have both abrasive and water mix, and they will give it the high pressure, again same as the water jet, and they add the abrasive. They have the mixing chamber and they will go out through here. For abrasive, they're using the aluminum oxide, silicon oxide, and garnet. A very fine grid size. They add on the abrasive. Okay, the other one is abrasive jet machining, in which they're using the stream of gas, okay, containing small abrasive particle. So they have the gas, and then the particles in the high speed, high velocity, usually performed manually by operator who direct the nozzles. And this one is usually for finishing process rather than cutting because they are aiming for the surface. Usually for thin flat stock of hard brittle material such as glass, silicon, ceramic, and the application is more on the finishing process of cleaning, polishing, trimming, and deflashing. Okay, we're done with the mechanical. Now we go to the electrochemical machining process. The definition is electrical energy used in combination with chemical reaction to remove material. So this one, they combine the electric and the chemical reaction, in which is the reverse of electroplating. Okay, you aware of the electroplating, so these are the reverse. And work material must be a conductor. So if not, it won't happen. And they need electrolyte, act as a current carrier, in which they need to wash metal iron away from the workpiece. So they have the anode and cathode. So under the electrochemical machining process, we have the ECM, the electrochemical machining. We have the ECD, electrochemical deburring, and we have the ECG, electrochemical grinding. Okay, let's look at the process. The first one, ECM, material removal by anodic dissolution using electrode. This is the tool, is considered as electrode, but separately by a rapid flowing of electrolyte. Okay, so the workpiece is the anode, these are the cathode, and they have the electrolyte. And how it operates, material is depleted from the anode workpiece and transported to a cathode. Okay, so they have the iron, okay, go into the electrolyte, So electrode material must be copper, brass or standard steel. And the tool have the inverse shape of parts. The application is for die sinking, irregular shape and contour, for forging die, plastic mold. And then many holes can be drilled simultaneously. And then we have holes that are not round can be used using this process, and deburring. So these are the diagram. So the electrolyte flow through the tools in which the cathode and the workpiece is the anode. Okay, the next one is ECD, the deburring process, same as the ECM. And this one is mostly for the holes and to remove some burrs or sharp corners. Okay, so they are doing the finishing process to remove this. Okay, they're using the tools again as the cathode, and the work is as the anode. And the last one in the electrochemical, we have the grinding for the surface, in which they use the grinding wheel with the conductive bond material, in which the anodic dissolution of metal parts surface. So this is the grinding wheel as the cathode, this one as the anode. So when it moves, it will have the iron metal dissolved in the electrolyte. So mostly on the sharpening of the cemented carbide tools for the lathe machine, and grinding of the surgical needle or other thin walls, tube and fragile parts. Advantages: depleting, responsible for 95% of metal removal. So grinding wheel is last much longer because they are not touching the workpiece. So that's all for the electrochemical. Next, we will look at the chemical machining.